This presentation looks at the best way we can design a printed circuit board or a PCB with Circuit Wizard and TechSoft PCB Design and Make. We first start off with a schematic or plan for the design. This plan has the components and the connections. In some cases we can even simulate the operation of the circuit. This is done with Circuit Wizard. We then in Circuit Wizard produce a PCB design which has the placement of the components, the pads and their tracks. We then export that to PCB Design and Make, in which we again look at the placement, look at the pads and the tracks, because we may need to manufacture the board by a variety of processes and we need to ensure the students can get the board working correctly. We now look at the design of the circuit board through the basic entry of the components. This is done with a schematic in Circuit Wizard. Let's look at a simple amplifier circuit and how we can translate that to a printed circuit board design. Here we have in Circuit Wizard a simple system: an amplifier, transistor, a LED, two resistors, battery, a push button and a capacitor. This circuit can be simulated to make sure it works, and as we push the switch the LED lights up because we're driving current into the base of the transistor. Now we'll go and do our printed circuit board export. We go to our convert circuit board automatically, and we'll do this as an automatic option: normal tracks, next, next, and we find the layout, although it proceeds automatically, is not that optimum. So what we'll do, we'll go through and do it manually and have a better layout using the rat's nest vision. So go back to circuit diagram, do another export. This time we'll do a rat's nest, no placement or routing, which will then present to me a picture of the printed circuit board with just the connections and the virtual connection through the rat's nest, as it's called. That's that green track we see here. So in this case we can rotate that resistor this way. We can bring in the second resistor here, rotate that, and you can see we've got the connection to that pin there, which you can do this way. We'll then get our light-emitting diode and say let's put our LED here. You can see the track goes straight to the LED here. The transistor, let's just put that and rotate that around a bit, so we've got now a track going directly to this point. This switch you can put down here, and this capacitor we're going to put like this, and see how this routes now through the route ornets. Got a better looking layout, easy to manufacture and easy to check. So now if we go into our artwork, we can see we've got most tracks quite even, etc. One thing we can be looking at is these pads are a bit too small, but let's leave it as that at this stage. So in order to do an export to PCB Design and Make, we go to the File, CAD CAM, Copy CAM Data option, and this translates the layout to the clipboard for pasting into PCB Design and Make. We've now gone through the placement of the components, the pads and the tracks, and now we're going to go to the export option through PCB Design and Make. Again do the placement, do the pads, tracks, and then create a manufactured board. We'll now paste our previously saved schematic into the layout, and now we see that the components have been placed as per the original location, and we've got these small pads for the transistor, etc. We may want to boost those up because they'd be quite hard to solder, so we go Start Edit, change pads, we make them small squares, and now it's boosted up the size of the pads. However, they're a bit too large, so let's do that again. Change pads, let's make them extra small, and likewise for this particular layout here, extra small, and there's our placement for our final layout in PCB Design and Make. It's always important to have a look at the layout in this particular package, because you're going to engrave the circuit board, and there's some locations where the tracks could get very close, so there could be an error here. So what we can do is we can actually select that particular pad and track and just drag that out a fraction, and that takes that out a bit, the location. So now it's a matter of going and doing the engraving, but it's also worthwhile checking the size of the holes. So if we go here and check the property, it's a 0.81 millimeters. This hole here is a 0.8. So if we're not careful, we'll do our selection of our drills, we'll get the 0.81, but we won't get the 0.8. So we can do that through our global change of the board by saying change pads, make them all circular, 0.8. These were larger pads for connectors, make them small. This was also a connection for a circuit, make that also small, and this is now a property of 0.8. So all the holes now are 0.8 millimeters. If we go to make PCB through the, say, the MDX 40, we define the engraving option. Be careful, this is rather fast for copper. And if we tick this drill number 1 to be 0.8, that will find the 0.8 millimeter holes and drill them. Make sure the printer driver is through the MDX machine that you have, or whatever, and now you'll have the correct location, plotting device, connection. Okay, you'll see now that the board has been inverted, showing the engraving tracks. We can check that the engraving tracks actually do make sense here. We can proceed with our making of our board. So in summary, our PCB manufacture with Circuit Wizard has several steps. We first define a schematic with Circuit Wizard. We then do our PCB export. We place our components and tracks either with auto placement or the manual routing, using the highlight rat's nest as guide to placement. We may wish to change the pads and the tracks in this particular process, and then we export our PCB into PCB Design and Make through the Copy Cam Data option. We then open PCB Design and Make. We can check the placement of our components. We may wish to modify our pads to make sure they are sufficient size for soldering and engraving and drilling. We verify the tracks that are not coming too close to any pads and producing problems, and then proceed to our manufacturing option.